Hello everyone, welcome to our live webinar of MAS in summer 2025. We would like to give you today a short overview of the future of via hole filling. First of all, we would like to introduce ourselves. We have today 3 speakers. First of all, I will thank you very much, André, for joining us today. André is our invited speaker. He is Managing Director of Adeon Technologies in the Netherlands. Then we have Dr. Tim Ohnweiler. He is Managing Director of MAS in Germany. And myself, my name is Max. I'm the Sales Director of MAS. Yeah, first of all, who is MAS? Yeah, short company introduction. The company MAS is around 40 years old and on the market. And we have 3 sectors where we can supply products for your needs. First of all, we have machines for the printed circuit board production and the microelectronics sector. The second part is the heat treatment, where we manufacture high-tech ovens and furnaces up to 1600 degrees C. We are starting from machines for drying applications and go on to high temperature heat treatments. And the third part is the automation and handling part. This is more or less a part where we combine the machines from the microelectronics area and also the machines for the heat treatment sector, especially when it comes to complete production lines. For example, a furnace will be integrated in a line. Here we also supply you the machines, for example, robots and handling equipment, which is necessary. Now I would like to hand over to André to talk about our really good partnership we have for many years. André, your job.
Okay, well, thank you very much, both Max and Tim, for inviting me and having the faith that I can bring a reasonable solution and a good presentation. Well, first of all, this slide is just capturing a few of the facts that we have with MAS. We worked together since the year 2002, and it says there heavy growth in via filling demand since 2005. What we saw in the very beginning was we recognized early that via filling was a technology that was going to grow, but it was at that time really for specialist type of designs, higher complexity, so a very low demand. But it has definitely increased, especially over the last 10 years, where the process requirements have been growing due to PCB design density, and also with the sequential buildups, also known as SBUs, but buried blind vias, via impact, etc., etc. So it has become much more of a common used process for most of the PCB fabricators today. So the beauty that we see with MAS already for a long time is that we have a range of equipment available from you guys, which the build quality for us is always perfect, but besides the build quality, what we deem more important is the application, the support, and the knowledge that we have been building as a team together, and we are still building and expanding on. And yeah, since 2002, we are now already at 24 years later since we started, and we've seen over 100 systems sold in Europe of the VCP type, the full vacuum. And as far as my information goes, of the pure VCP systems, you've already sold more than 300 in worldwide. So yeah, that's a little bit of the history and where we come from together with MAS, and why we see this also still as a growing opportunity, a further growing opportunity. And that means for us and for you as customers, I think you will recognize these pictures, the definition of via filling, and where do we apply the via filling? Well, there is a range of product that needs via filling nowadays. So it can vary from through holes to buried vias, blind vias, micro vias, where typically blind vias will have to be done, processed and filled prior to the further sequential pressing steps. And what you also see on the picture below is that, which is beautiful also for the mass equipment to be used in, for non-conductive paste and also conductive pastes. It is fair to say that we see in Europe at least the majority being used with resin paste. And there are several resin type suppliers in Europe, but actually also worldwide, with whom we all have very warm connections and good R&D combinations to develop further, but also that we understand what is required. Because paste is not just paste. Paste has different viscosities, different characteristics from different suppliers. So, and through the process steps that we are seeing, and there in blue you see the three, number 2, 3, and 4, the main process steps is the via plugging, the curing, and the planarization, which is typically what we offer with the mass equipment. But also a little bit important is to understand what is required before the filling itself. It's really crucial that the holes are completely dry, that there's no moist in the board that can disturb the via filling after it's been fully cured. The curing itself is a relatively straightforward, is a thermal process, but also surface planarization. It says if needed, but basically it is always needed after the full bake. Yeah, so there we have a few steps added about the process itself. So you really, first of all, can look at the reference descriptions used in the IPC 4761, called the via protection type classification. So there in detail is described at IPC classification what is required for the via filling processes. One advantage we believe is that UL certification is not required. We do get that question many times from customers, but UL serves different purposes and it's not required for the via filling. So really what you would need to do for the process is that you drill first only the vias that need filling. That is the best. Additionally, we also see that there is a fairly wide spread in different diameters that we can fill in one single pass. But obviously, depending on aspect ratio of hole size and panel thickness, there might be some variations and some limitations to the process, which are very important to understand. Prior to the filling, we've learned a lot, basically in Addion, where we do quite a lot of work with plasma for PCB, is that plasma can also be used as an ideal preparation prior to filling, or baking the panel so that really, as I mentioned before, all the moist is removed from the panel. That is really crucial. And then the via plugging with a resin or a conductive or even a non-conductive paste can take place. And after the via filling itself, you do another fully cure, a thermal cure at roughly 150 degrees for 1 to 1.5 hours. After the planarizing step, I apologize, I have to go back. After the curing step, the planarization is required, because what you don't want is any resin residue remaining on the surface. Depending on the type of process and the type of application, there can always be a little bit of paste residue which needs to be removed, and that's called the planarization process, for which MAS also offers a machine, and that brings you to a real flat surface, so no bumps, but also no dimples. And some important parameters, as mentioned earlier about aspect ratio, the hole and the panel thickness. This is very important to understand what type of recipe is required for the machine. In the MAS machines, the beauty is that you can set up an unlimited amount of different recipes, which describe the speed, the pressure, and the temperature, but also you can have different recipes based on the different resin types that you're using. For instance, a paste from Peters might be a little bit different than a paste from Tayo or from Sanai. So it's really also important, first of all, and this is one of the key elements for us with the MAS machines, is that we have the full chamber under vacuum. Now, Tim will later on go a lot more detail about the true parameters and the true calculations and maths and facts behind it. But for us, it simply means that if you can have a full chamber under vacuum at the most maximum achievable air evacuation, this is a big advantage for the process, especially for blind vias, because you're not pushing it through, so your paste has no way to escape. It has to go in, but the air has to be out completely. Yeah. Huh? And with that, the filling speed is important, and also these can be defined by type of panel aspect ratio, but also the size, number of holes, etc. And very important is that you have a stable temperature, because if you have a chamber under vacuum, you can keep the temperature basically very stable at the environment where the machine is situated, where it's located. If you don't have the full vacuum chamber, you will have to have the heads with only vacuum. But if you have the heads with only vacuum, you get a phenomenon that heats up the heads. Also, because you have to go on a slower speed in order to be able to fill everything as good as you can. But bringing in heating up the paste also requires that you need cooling to the head. So that makes another requires another step in the manufacturing of these print heads, where of the filling heads, where you have to add the cooling devices to it, and that means that also cooling fluid will be flowing through your machine, and it's not really ideal. So really having the chamber under vacuum eliminates all of those steps and really gives you the opportunity to fill in one step with a maximum result. And therefore, you also need a robust equipment design. There's also a reason that we work with MAS since 2002. The machines have always been very robust, but recently we've seen more developments even on the front to back strength of the faceplates that we are using for the filling in the heads. We call them the faceplates. Also the feeding of the paste, which we always strive for perfect paste distribution, and achieving it in a single pass, and to keep full control over the paste consumption. But it means you have to have a real even distribution of the paste over the whole panel, and that's what we also achieved with the new developments, of which also Tim will elaborate a little bit further in the next coming slides. And just as a brief overview, MAS is not just offering one type of system. With the knowledge that MAS has built up over the years, it's been able to develop a range of different systems, where you see on the left top side the big runner, really the most used system in the world, I would say, the VCP 5000, with in the center part the filling, and on the left hand side of it you see the scavenging. So the right hand side part is really the vacuum chamber where the filling takes place. Once the filling is done, the panel can be removed and located into the scavenging to remove the first layer of excess paste prior to putting the panels in the oven. On the right top side, there's a fairly special development, making use again of a full vacuum chamber, but allowing also, with the use of stencils, to have selective filling. And especially in some high-tech, high-end applications in Asia, and also some in Europe, linking more even to semiconductor type industry than to printed circuit board. We see that selective filling is something that is also seeing a growing demand. Then on the bottom side, we have the VHF 3000, which is also a single-sided machine with a single head, in which you can also choose the type and size of head that you'll be using. And on the left bottom side, I've still kept this one in, because there are still applications for only through-hole filling. Now, for through-hole filling, it's not completely mandatory or necessary to have a full vacuum chamber. Also, again, depending a little bit on the aspect ratio, but we have this little, what we call entry-level system, the VHF 200, which is still used by a fair amount of customers, but limited basically really to do through-hole via filling only. And in the center part, last but definitely not least, is a planarizing device, which is very important to achieve the uniformity and the flatness of the filled holes after the filling and the baking and the processes have been done. This machine is really a relatively straightforward, simple design, but it offers a full vacuum chamber, full vacuum table, so that the product can be laid really flat and can be held flat, but also the process is coming with water feed coming through the head, and the water feed through the head actually gives a very nice effect. It creates a sort of a shiny, more shiny image, so that when you are planarizing, you see immediately with the naked eye, have I really planarized everything away that needs to be planarized away or not? Because this is also very delicate. If you planarize too much, you kill one knee of the hole, you can kill your product. But if you don't do enough, then you are creating problems for sequential processes. So this machine is really what we always call everyone's friend, to be used in the planarizing to finalize the wire filling process.
Okay, yeah, Andre, thank you very much for these insights and this short overview about our products. I would like to go on in the next slides, to highlight a little bit our VCP, our vacuum chamber plugging machine, and explain you a little bit. Andre started already with it. Well, now I will go a little bit more in detail and explain you all the areas and the functions of the machine. So how it works. So what you see, Andre mentioned it already. We are talking now about this machine here. So we have here a complete vacuum chamber. The PCB board will be moved inside the vacuum chamber in the first production step. We have here on top clamping. So the worker takes the PCB board, moves inside, clamps the board. Then we close the door of the machine. It's a fully PLC controlled machine, so a complete automatic process. So we close as a next step the door, and then we pull a vacuum. And depending on which type of boards you want to plug, Andre already mentioned it a little bit. You can define in the software the vacuum level which is necessary. It also depends a little bit on the paste you're using. So you pull a vacuum first of all, and this is a very important step which I want to highlight here on this slide, because we extract all the air and also a little bit the moisture of all the holes inside the PCB board. And this has a huge impact and effect, first of all, for the quality at the end of the plugging. So now we pulled a complete vacuum inside the chamber, and we extracted all the air of these holes. And now you see we have here a traverse, which is moving during the evacuation step automatically upwards. And you see it here on the schematics, very nice on the right upper side of this slide. We have two filling heads, one in the front and one in the rear of the PCB board. And these filling heads will move now, next to the surface of the PCB board, seal on the surface. And after this step, we are applying a paste pressure from both sides, and then the paste will go in all the holes of the board. And here, the biggest advantage of our machine is definitely the vacuum, because Andre explained to you, for example, when you have blind vias, we extract first of all out of these holes the air, and press now the paste inside these holes. When we would not have a vacuum here, we would generate an air bubble, because when we press paste inside a non-evacuated hole, you generate the air bubble, and this causes problems at the end. So the vacuum is here a huge benefit for you during the plugging process. When we apply the paste pressure, we are moving slowly down with our traverse until all holes of the boards are filled. After that, yeah, we fill back the chamber with normal air and open the door, and then the worker can extract the PCB board out of the vacuum chamber. You see here where my mouse is at the moment, and moves to the external squeegee unit where we do the squeegee process and where we get rid of yeah, a little bit of a paste film on the surface of the board. On this slide, you see an evacuation curve of our vacuum chamber. Yeah, so this is a real data recording of our machine. You see, yeah, for a typical process, we need around 40 seconds until the vacuum chamber is evacuated from normal ambient room conditions to the process vacuum level which is required. Yeah, Tim, now I would like to hand over to you. Please give us some insights of some basic vacuum technology and also what is the physics behind of it.
Yeah, thank you very much. First of all, I want to thank André. It's really a big pleasure for us to have such a partner on board. This is very important for us. And how to improve a machine. Improving a machine only works if you really listen to the needs of your customers on site. And this is where André helped us so much over all of the years. And we will also present a new generation of our VCPs. This is what Max will do at the end of the webinar. But I want to use the possibility to really say thank you for this partnership. Many years. It helped us to improve the machine step by step. And I think that is also where we are. We are prior to launching a new generation of machines, which would not be possible without André.
If I may quickly interrupt, also, it takes two to tango, Tim, so it works together.
But before we go to the new machine and about the new features, I want to go back to the basics. Yeah, what are really the basics of vacuum technology, which is really the key of our VCP machine, the full vacuum chamber, which was mentioned by Max. And I want to go back to really physical basics of vacuum technology. When we start here at the pressure of 1000 millibar, which is atmospheric pressure, and here you see that's a typical via, yeah, and a typical via has a diameter which is 2 times the radius of it. And of course, you have, first of all, you have a lot of air molecules inside the via hole, yeah. And then we start to switch on the vacuum pump. And the question is what happens? And at the beginning, I think it's very easy to understand because at the very beginning, I call it always the Hoover effect. Yeah, this is nothing else than the Hoover. I switch on my Hoover and all the molecules or even the dirt, it just comes in. Maybe one picture which is interesting, if I have my Hoover here above the surface of the table, the dirt would even come out here if I do not touch it. Yeah, and the reason for that is that at the beginning I have the so-called laminar flow. You see here the flow profile is a laminar type of flow profiles. Maybe there are some turbulences at the edges, but first of all it's very easy and it also goes very fast. Yeah, because the air is really sucked out of the via hole. That is, I think, everyone experiences also in daily life. But the question is, if I have less and less and less molecules inside my via hole, and this is the other extreme, yeah. And here at the left side, we are at very low pressures, yeah. That is really the high or the ultra high vacuum range. And now there is no Hoover effect anymore. I think that's very important to understand that the Hoover effect is over. Yeah, so even if I have in high vacuum, the strongest pump here, the molecule which is sitting on the table would not come towards the pump. Yeah, because the reason for that is that there is no flow mechanism anymore. This is now only what happens now. This is now only a statistical movement of the molecules inside the via hole. Yeah, so it's not like having the Hoover. Now it's more like catching a single molecule. And that is what is here. Yeah, you see here the girl running behind the chicken. If you are lucky and if you are fast enough, you can catch the molecule, but it's only a statistical effect and there is no suction effect anymore. And of course, there is now an intermediate range, which is called the Knudsen range. The most important message for me today is that the plugging area is here. It's between, yes, let's say, 10 and 100 millibar. So we are plugging in the area, which is exactly the intermediate area between a viscous flow and the molecular flow. So I made some simulations. And of course, at the beginning, I said the evacuation is very fast. But in this intermediate range where we do the plugging, yeah, it starts to become slower. And here you see a typical via, and you see here the lines. These lines are really the trajectories of the molecules inside the via hole. It's a FEM simulation of those trajectories. And then I was making, let's say, pictures after 1 second, 30 seconds, and 40 seconds. These are really pictures. And then you see after 1 second, the particles are still inside the via hole. If you wait a little bit a longer time, the particles were moving along the trajectories, yeah, statistically distributed, yeah. And of course, then it means after 30 seconds, less molecules are inside the via hole. And the same is true after 40 seconds. So the important message here is, and this is just a technical fact, that taking out the molecules outside the via hole, it takes time. And there is no way to come around that. It's just a technical fact. And that is why we at Mars, we developed the full vacuum chamber plugging, because we really say it needs to, you need to give some time for the air molecules, and more important, for the moisture, for the water molecules to be removed from the hole. This is, I think, the most important message I want to bring here over, that it takes really time to get rid of those molecules. There is no way around that. And this leads to several advantages for the Mars VCP machines. So why do we use the full vacuum chamber? Vacuum technology is not so simple. Yeah, you need to have some basic understanding. You need to have some, let's say, technologies to enable vacuum inside your machines. But the advantages are very clear. Max showed the evacuation curve, and he said that approximately 40 seconds our via holes are under vacuum before we start the plugging. And of course, compared to if I have a vacuum only locally applied to a hole, where it's maybe subjected to a vacuum for 1 or 2 seconds, of course, after 40 seconds, I have less molecules inside my via hole. And what does less molecules mean? What is the number behind? And the number behind is huge. After 1 second, you see here, you still have 1.696 trillion of molecules inside a typical hole of 3 millimeter diameter and 2.4 millimeter thickness of the plate. Inside the Mars machines, you can subtract 1.679 trillion molecules from this number. So in the Mars machines, you really have trillions of molecules less inside your hole. So what plugging you want to do? I think the answer is very simple. Of course, this has also some other effects. For instance, in the full vacuum chamber, the cycle time is much lower because we can move a little bit faster with our head. It was mentioned by André, because there is no heating up of the head anymore. Because it's very clear, when you start to evacuate in the viscous, in the laminar range, there is a lot of movement of the molecules. They really move, they hit the surface, and they heat it up. So we don't have any heat up in our system, so we can move a little bit faster, our cycle time goes down. Further, the design of our filling head is very easy because it's just a filling head. It's very simple. It's simple to be removed. It's simple to be cleaned. So more or less, it takes only 1 hour. So here, cleaning is very fast.
And that is for the cleaning process, the swapping of the head to a different dimension.
Yeah.
Yes.
Is 2 minutes.
Yes. Yeah, the myth of high vacuum plugging. I think there is really a mythos about what is the correct vacuum setting when you do the plugging. And of course, you see, technically speaking, there is a distinction between 4 different vacuum regimes. Yeah.
Yes.
First of all, we have the rough vacuum. I explained it. This is the vacuum level where the Hoover effect is still alive.
Yes.
Here we can have the Hoover effect. The Hoover is approximately working at 1000 millibar, maybe 900, something like that. Below 1 millibar, we talk about the fine vacuum. And below 10 to the minus 3 millibar, we talk about high vacuum. And when we talk about the vacuum level less than 10 to the minus 7 millibar, we talk about the ultra high vacuum. And of course, the lower the vacuum, the more complicated the technology gets, the more expensive the system gets. But of course, the less molecules you have inside the VR hole, that's also clear. Yeah. So the big question is, the easy answer would be, the better the vacuum, the better is my plugging result. But there is also another effect. So imagine we have a bottle of water. Yeah, we have water. Everyone knows when I here in Anröchte, where Mass is located in Nordrhein-Westfalen in Germany, Anröchte, it's a height of almost 200 meters above the sea level. So the water in Anröchte at Mars, it starts boiling maybe around 100 degrees C. Now today we are invited here in the Netherlands. I think you are almost at sea level or a little bit lower.
I don't want to scare you, but we are below sea level. I checked this morning and we are still safe today.
Yeah.
So
Okay.
Holland might be there tomorrow still.
Okay. So maybe we are sitting here together with André at Adion Technology. Maybe water starts boiling already below 100 degrees C.
Yes.
We can try it.
Yes,
We can try. If you are on the Mount Everest, which is 8.8 kilometer height, water starts boiling already at 70 degrees C. And the important message here is, of course, the same effect is also true for our paste. Also, our paste has a so-called vapor pressure curve, and the blue curve is the water curve. The red curve is a typical curve of a typical non-conductive paste which we are using at our VCP. And of course, there is also, if you reduce the pressure, there is a certain point where the paste starts boiling. And here you see this was tested in one of our machines. So approximately at 2 millibar, maybe 3 or 4, between 2 and 4 millibar, the paste simply starts boiling. And that is effect you will see here at the end of the video. You already see a little bit where it starts, where the boiling starts. And now you clearly see there is more and more boiling here. So now we are at 2 millibar. Now we are maybe at 1.5 millibar. You clearly see that there is a vapor pressure of the paste itself. It starts boiling. So high vacuum plugging makes no sense at a certain point. It makes no sense below the vapor pressure of the used paste because it would start boiling. And that would even be worse. So you need to do the plugging above the vapor pressure of the paste you are using. So of course, these pressures are also different. They depend on which paste you are using. And also the advantage of our vacuum chamber is that you can exactly set the pressure you want. And if you have a localized vacuum, you don't know which pressure you have, because it depends on the time, it depends on how fast you are driving, so you don't exactly know. Yeah, we at Mars, we can, in our software, we can really adjust the plugging pressure you want precisely by the precise vacuum gauges which we are using, by the sensor technology we are using. So you can adjust the vacuum level to your process, to your paste, to get the optimized results. So for me, the message here behind is there are two reasons why ultra high or high vacuum plugging is technically not possible. The first thing is it cannot be achieved in a reasonable time. We want to plug our plates. We don't want to wait forever. But the second argument is really the vapor pressure of our paste.
Yeah, Tim, thank you very much for these insights and explanations about the physics behind new machine generation. We will call our VCP M+. Yeah, so this is really the next level of vacuum plugging. What are the improvements? Yeah, so we worked hard with our team to reduce overall the paste consumption during the plugging process. This is very important for you as a user of the machine because buying paste is an expensive point, and when we can reduce the paste at the end, you will have a big or a huge benefit here. We also worked on the improvement of the vacuum, especially vacuum sealing and so on. So we did hear a lot that the new machine bring you here a lot of benefits from the vacuum technology side. And big improvement will be also our new software generation of the new VCPM Plus. So you have here a lot of possibilities in the future to monitor your plugging process, to analyze the paste consumption after a plugging process, and so on and so on. But all these details, we will present together with André and Adeon on the Productronica this winter in Germany. So please visit us here in Hall B3 at our joint booth where you find MAS and also Adeon. And here you see the machine first of all, yes, and you have also the possibility to get in touch with us, and we explain you all the new functions and features of the machine.
If I may quickly add,
yes,
Max, also what we learned with the software, the new software, very fashionable words, Industry 4.0, 5.0, but also MES systems. The new software is really enabling for us to have a lot of the traceability of all the parameters, to be able to pull them out, to analyze them further, but also in the future to connect further to management execution driven systems.
Yes.
So.
An important point to highlight. Yeah. On this slide, you see some first insights of the new software. Yeah, so the new software will be very, very easy to use. The user interface is designed to operate very simple, and optically you see here you can directly select sections of the machine. You don't have to read many manuals. No, the software is very intuitive and easy to use. We already said so some couple minutes before the software will also help you to reduce, for example, paste consumption. The software will give you insights of all the process parameter which were generated during a plugging process. And so you can see here directly in front of the machine, and also afterwards, of course, in data recording, which pressures you have used, for example, for a plugging process, which traverse speed you have used. So it's really an easy and nice overview for optimization and also for process control at the end.
And to this slide also, you increase the traceability. Yeah? So
Yes.
all these little new features in the software are really the result of many discussions and many developments that we've had over the last.
Yes, of course. And we would also highlight one important point is our new MAS demo center, yeah, in Germany. We already had a lot of customers in our demo center, and this demo center is for you. So you have the possibility to come over. You are very happy to visit us every time to make with us trials, yeah, on the machine. Yeah, so you can bring your panels with you. And we do, yeah, with the paste you want to have. We have, yeah, all the common pastes available at MAS. And in the demo center, here we can really do application development, process optimization, feasibility studies, and so on. So we can do plugging, we can queue the curing steps, and also the planarization steps. So all the machines are available. And yeah, the customer feedback was really good because yeah, with these tests in advance, the customers have the possibility, first of all, to see the machine before and purchase, to check the quality. So this is really for both sides a really good chance to optimize or to see the machine. If you have any questions now, yeah, we are here to answer you all the questions. So if you have anything, please come up with the questions.